Hey guys, welcome back to lecture series on numerical solution for differential equation. Okay, so in our previous part guys, I explained to you all the solution for the differential equation using the Runge Kutta method for simple differential equation. Okay, and in my last lecture guys, I explained to you all second order Runge Kutta method for solution of a simultaneous differential equation. Okay, so in our today's video guys, I'm gonna explain to you all its extended part. Okay, like a fourth order Runge Kutta method for solution of a simultaneous differential equation. Okay, so without further ado, let's get dive into our today's lecture. Okay, so we're gonna first of all see what we have to do, and then I will explain to you all the Runge Kutta formula for fourth order. Okay, so we know that the simultaneous differential equation. Okay, so consider simultaneous differential equation. Okay, consider simultaneous differential equation. So we know that simultaneous differential equation can be written as dy by dx, which is equal to f of x by z, and consider another function dz by dx as a g of x, y, z with having initial boundary condition as a y of x naught which is equal to y naught and a z of x naught which is equal to z naught. Okay, these are the two boundary conditions for our given symmetrical simultaneous differential equation. Okay, so I'm going to define fourth order formula. Okay, fourth order Runge Kutta formula. Okay, fourth order Runge Kutta formula. This one is very much important guys. Okay, so as I already explained that we have to go for the similar replacement of the variables. Okay, fourth order formula. So we know that for finding the fourth order we can use the 1 by 6 plus k1 plus k2 plus k3 plus 2k2 plus 2k3 plus k4. Okay, so that one we have to define here. Okay, so let me write what are the value that we are going to define for our formula. Okay, so we know that the solution as a first solution, consider it as a y1. Okay, y1 which is equal to y naught plus h by 6. Okay, why we take y naught plus h by 6 under bracket k1 plus 2k2 plus 2k3 plus k4, k1 plus 2k2 plus 2k3 plus k4. Okay, this one is the required solution for our given simultaneous differential equation. Okay, yes, so as we have two differential equation, always remember guys, we'll get the two different solution. Okay, so consider first is y1 and the second another one is considered is a z1. Okay, z1. Okay, so we write that z1 is equal to z naught plus, it is similar like this one. Okay, plus h by 6. Okay, z naught plus h by 6. So we are defining l1, l2, l3 and l4, three variables, four variable, l1 plus 2 l2 plus 2 l3 plus l4. Okay, these are the four variable. Okay, these are the two required solution for our fourth order Runge Kutta formulas. Okay, yes, now see that guys, as we have two solutions, okay, involving k1, k2, k3, k4, l1, l2, l3, f4. Okay, so that we need to know what is the mean by k1, what is the mean by k2, k3, k4. Okay, so let me write k1 first. So I'm going to write k1 and l1 at a time so that you can relate the concept and you can remember these formulas. Okay, yes, so k1, let me write k1 first. Okay, h of f of x naught, y naught, z naught. Okay, so I'm going to consider k1 as h into f of x naught, y naught, z naught, h into f of x naught, y naught, z naught. Okay, this one is our k1. Okay, h into f of x naught, y naught, z naught. So similarly I'm going to define l1 here for this z1 also. Okay, h into g of x naught, y naught, z naught. Okay, this is the l1 for this z1. Okay, that l1 and k1 I define both over here. Okay, we want k2, l2, k3, l3, k4, l4. Okay, so let me define k2 now. Okay, k2 we know that h f of x naught plus h by 2, y naught plus k1 by 2, z naught plus l1 by 2. Okay, x naught plus h by 2. Okay, y naught plus k1 by 2, y naught plus k1 by 2. So you will get the k1 from here, okay, y naught plus k1 by 2, and z naught plus l1 by 2, okay, and that you will get l1 from here, okay. X naught plus h by 2, y naught plus k1 by 2, z naught plus l1 by 2, okay. So I want the L2 also, as I have L1, then I want the L2 also. So we are going to define only G here, okay. H into G of x naught plus h by 2, y naught plus k1 by 2, z naught plus L1 by 2, okay. X naught plus h by 2, okay, x naught plus h by 2, y naught plus k1 by 2, and z naught plus L1 by 2, okay. So these are the K1, L1, K2, L2, okay. Now we want the K3, L3 now, okay. So I'm going to define K3, okay. So see that guys, it is very easy, not that difficult. Need to just focus on the trick, okay, how I'm explaining the values. K3, okay. So K3 I'm going to write H into F of, okay, x naught plus h by 2, y naught plus k2 by 2, and z naught plus l2 by 2, okay. X naught plus h by 2, y naught plus k2 by 2, and z naught plus l2 by 2, okay. This one is K3. So I'm going to define L3 also. H into G of x naught plus h by 2, y naught plus k2 by 2, z naught plus l2 by 2, okay, z naught plus L2 by 2, okay. These are the K1, K2, K3, L1, L2, L3. I got it here, okay. So we have left here the value for K4 and L4, okay. Let me write K4 again. These are the similar guys, not that difficult to remember, okay. So K4, which is equal to, we write H into F of x naught plus h, y naught plus k3, z naught plus L3, okay. H into F of x naught plus h, okay. We keep x naught plus h as it is, y naught plus k3, and z naught plus L3, okay. X naught plus h, y naught plus k3, z naught plus L3, okay. This one is K4 and L4, okay. I'm going to define L4 as well. H into G of x naught plus h, y naught plus k3, and z naught plus L3, okay. This one is the value for L4. I hope you all have understood guys. This one is our required entire formula, fourth order Runge Kutta formula, okay, for finding the solution of a simultaneous first order differential equation, okay. Now you can see here, for your reference, you can note it down the point. I hope it is quite confusing at the beginning, okay, but once we solve some of the example guys, the concept will be the crystal clear, okay. So we go for some of the example in our next lecture, but this lecture it is I completely devoted for the method only, okay. Yes, it's not that difficult guys, you just need to understand the methodology what we have given in our methods, okay. So see that this one is our fourth order solution, fourth order Runge Kutta method for solution of simultaneous first order differential equation, okay. The differential equation I consider over here, okay, and for this differential equation boundary condition, and fourth order Runge Kutta method for their two different solutions, okay. For y1 I introduce k1, k2, k3, k4, z1 I introduce l1, l2, l3, l4, okay. L3 and L4, okay. So if you want, you can pause the video guys, note it down what I have written. This one is very much important for your end sem exam, okay. I hope you all have understood everything here in my today's lecture guys, okay. So even after, if you found anything difficult, anything confusing guys, let me know in my comment section, okay. If you find anything difficult, anything confusing, let me know in my comment section. I will come up with the similar videos. So that's it here for my today's lecture guys. So thank you everyone, thank you for my today's lecture.